Welcome back to The Deep Dive. Today we're diving headfirst into the online Encyclopedia of Integer Sequences, the OEIS.
The OEIS. Fantastic resource.
Absolutely. It's incredible for anyone fascinated by numbers, and especially for you, our listeners studying number theory. It's just, well, it's a goldmine. Our focus for this deep dive is a specific entry. OEIS sequence A000286. Now, its definition, it can sound a little dense at first.
It can, yeah.
It's the number of positive integers less than or equal to 2 canis of the form 2x stout plus 5y family. Okay, let's unpack this a bit. Our mission is to clarify what this sequence is really about and, why it's quite interesting.
Well, what's fascinating here is that we're not just counting random numbers.
Right.
We're looking specifically at integers that can be expressed in this particular way, this quadratic form.
Yeah.
2x plus 5y damio. You can think of a quadratic form as a kind of mathematical recipe.
A recipe, I like that.
Yeah, for building numbers. You square some variables, x and y here, and combine them with coefficients, the 2 and the 5. And these recipes, these forms, they're really fundamental in number theory.
Why is that?
Because they show us deep things about how integers are structured, how they're distributed. So counting how many integers up to a certain limit, like 2n, actually fit this specific mold, well, that's a powerful way to probe those properties.
That connection to structure, that's what makes it more than just a list of numbers, isn't it?
Exactly.
So to give you a feel for how A000286 behaves, let's look at the first few terms, starting with n, 0, the sequence goes, then 1 again, 4, 5, 11, and it keeps going. Each number is telling you the count of positive integers up to that power of the 2n bit that you can write as 2x set plus 5y ben.
Right. So for n3, that's 2 cubed, which is 8.
Yeah, up to 8. And the sequence says the term is 4, so there are 4 numbers less than or equal to 8 that fit the form.
And the sequence isn't new. It has some history within the OEIS itself. It used to have other names, n3251 and n3012.
Oh, interesting. So it's been cataloged for quite some time.
Definitely. And its significance is really highlighted by its inclusion in Neil Sloan's foundational work. We're talking a Handbook of Integer Sequences back in 1973.
A classic.
Absolutely. And then again in the Encyclopedia of Integer Sequences, which he did with Simon Plouffe in 1995. Being in those, well, it cements its importance.
Okay, here's where it gets really interesting, I think. The sequence isn't just sitting in a book. It's actually been used in mathematical research, hasn't it?
That's right.
I saw a connection to D. Shanks and L.P. Schmid's work, their 1966 paper in MathComp, Variations on a Theorem of Landau, Part 1. How did A000286 actually figure into their work on Landau's theorem?
Well, in that specific context, A000286 serves as a concrete example. It helps illustrate how the numbers represented by this specific form, 2x, say, plus 5y viewed, are distributed.
Ah, so it's about density, like how common are these numbers?
Exactly. It helps mathematicians analyze those kinds of density questions.
Yeah.
As you look at larger and larger ranges of integers, how often do you encounter numbers of this particular form? And if we connect this to the bigger picture,
Yeah.
A000286 is a great example of what we call sequences related to populations of quadratic forms. It gives you something tangible to understand the statistical behavior, the distribution patterns of integers that come from these specific algebraic expressions. It shows how numbers built with squares involving 2 and 5 behave.
And that really underscores how useful the OEIS itself is, right? As a tool for anyone digging into number theory, it's maintained by the OEIS Foundation, Inc. It's constantly growing, a living database.
Couldn't agree more. It's indispensable.
So for you, our listener, what does this all mean? Fundamentally, sequence A000286 gives us this precise, historically recognized way to count integers you can write as 2x plus 5y5. It sheds light on a specific corner of number theory dealing with these quadratic forms.
And, this raises an important question, I think. By exploring specific sequences like this one in the OEIS, you're not just learning facts about patterns. No, you're actually sparking your own critical thinking. You start to see the deeper structures, the intricate rules that govern the world of numbers. It's about connecting these specific examples to, well, larger mathematical truths.
Exactly. Which leads to the final thought. How might understanding these specific kinds of number forms, like 2x sot plus 5yf, open up new mathematical questions, or maybe even applications in your own studies? Perhaps this deep dive is just the start of your next mathematical curiosity.